Sure. So you saw we're doing STEAM. So STEAM for science 3. So what's happening here is we are required to calculate energy values which take place within extremist conditions. So these are the formulas which we need to make sure we know. We have the first formula, enthalpy of wet steam, where you say HF plus QHFG. The same formula you might see it elsewhere written as You'll see the same formula being written as H wet equals to HF plus X HFG. Sure. So in this regard, this X is still the same value as this, which is referred to as the dryness fraction or dryness factor. So dryness fraction or dryness factor. Then they'll tell you calculate the enthalpy of dry steam Hg, which is HF plus HFG, enthalpy of liquid steam, and enthalpy of evaporation steam. Then we have enthalpy of superheated steam. You use this formula here. We are given specific heat capacity. They will also give you TSU in the question. This two information, they'll make sure you have it. And then there's enthalpy required, additional enthalpy required to wet steam. Enthalpy required to wet steam. Then lastly, enthalpy, we have HSS, enthalpy required to superheat steam. So we do have one for superheated steam and one which is required to superheat steam. So you need to make sure you know your formulas. I think the only thing I may have not written here is that Q, which is the dryness fraction. Sometimes they will say factor. Yeah, so that's as much as you need to know. These are your formulas. So how they work is they will give us a pressure value, and from the given pressure value we will then refer to a steam table. So on a steam table, it's a yellow books. They'll give us these yellow books to examine. And so from the steam table, we need to refer to a given pressure. From that given pressure, let's say we use the pressure for 200. Pressure for 200 is here, there. So you will take your ruler, place it directly under the 200 so that you can clearly see all your information at the pressure of 200. So then you will notice at the top we have TS, the saturated temperature. We won't be going into volume values. Here we have your HF, liquid enthalpy, HFG, evaporation enthalpy, and your HG, your dry enthalpy. So the information you'll be referring to your steam table as you go about your calculation. So let's just try one question quickly. Yeah. All right. So question number 1. Maybe let's do this. Yo. So we want to try answer this first question quickly. All right. Sharp. So here we have our question here. So it says steam is generated in a boiler at a pressure of 270 kilopascal. They gave us a pressure there. So we have a pressure. Our pressure, we have 270 kilopascal. At a dryness fraction, we have our Q value of 0.94. It says calculate the following: the enthalpy of the dry saturated steam. Next one says calculate the enthalpy required to convert 2 kgs of water into wet steam. So let's start. 1.1, it says enthalpy of the dry saturated steam. You check on your formulas there. Dry saturated steam, we know it as SG. Enthalpy of dry steam is this one, enthalpy of dry steam. So you have the option of either going through this whole formula or getting your Hg value. So remember, they gave us a pressure of 270 kilopascal. We go to our steam table. Let's look for our pressure for 270. So 270 here, 270. So you will just align your ruler to 270. There. I'm looking for Hg. My Hg value is 2720. So to write my answer, which is confirmed here on my notes, my Hg is 2720. They've given us the SI units on the steam table. The SI units are already presented at the top, kilojoules per kg. So you may write that SI unit as you see it. This is kilojoules per kg. These are the same as our heat value SI unit values. So next question, 1.2, it says the enthalpy required to convert 2 kg of water into wet steam. So this is what you do. You want to convert 2 kgs of water into wet steam. What you do is you first find the enthalpy of the wet steam and you multiply it by 2 kilograms. So enthalpy of wet steam, this is our formula. We're saying H wet equals to HF plus Q, HFG. H wet equals to HF plus Q, HFG. You check your information there. Our HF, what do we have for HF? We have 546. We have 546. So it's going to be 546 plus our Q value, we have 0.94 times our HFG. Our HFG, we have 2174. We have 2174. 2174. You type your calculator. When you type your calculator, 546 times 0.94. Yo, it's not times, this is plus. Times 2174. And our answer, we are getting this value. This is 2589,56. Let's write it here. 2589,56. So this is measured in kilojoules per kg. So now remember, it says to convert 2 kgs of water. So all you do is you multiply it by your 2 kg. When you multiply it by the mass times 2, you will get the answer 5179,12. Let's confirm so that you guys can see it. We're saying times 2. And this is the answer we got. So you'll then notice this expression is measured in kilojoules per kg. This one is in kg. These kg values will cancel each other. Thus, you'll be left with kilojoules. And so that's how you go about this question. Let's try another one quickly. Yeah. So for this one, let's see what it has for us. All right. So steam, it's not difficult. Imizamanyana cell. Sharp. So let's see, they gave us a mass of 10 kg of water at a pressure. Given pressure, we given 920 kilopascal, and the temperature, we just given a temperature of 60 degrees Celsius, is heated to boiling. Then the dry saturation point is heated to boiling point. Then to dry saturation point and then to superheated steam at a temperature of 210 degrees. So then to superheated steam at a temperature. So to superheated steam, it helps us to find our TSU, that's 210 degrees Celsius. We know this is as soon as it reaches superheated steam. Then it says determine the enthalpy, heat energy of the following. Then 2.1 comes. 2.1 says calculate the liquid enthalpy. So liquid enthalpy, then it is expressed as HF. HF. So liquid enthalpy, you're looking for liquid enthalpy at a pressure of 920 kilopascals. Remember that we are doing this to convert 10 kgs. So you go to your steam table, we're looking for 920 this time. So you will scroll 920, just around here we have 920. Let me just do this. 920. So there. Technology is failing me. We have 920. Sharp there. So HF 747. So for our liquid enthalpy, we have 747. It's measured in kilojoules per kg. Because they gave us this 10 kilograms, you'll multiply your enthalpy value. Thus, it gives us 7470 kilojoules. The kilograms, they still cancel each other. So you'll only multiply this much to enthalpy values. You won't multiply it to a temperature if they require you to find a temperature, but only enthalpy values. 2.2, enthalpy of evaporation steam, we know it as HFG. We go to our steam table. Our HFG, let's see, HFG is in this line. We have 20, 26. You have 20, 26 kilojoules per kilogram times 10 kg. You have 20, 26, 0 kilojoules. Yeah. So I waited today. It's not difficult, man. 2.3. 2.3 says the enthalpy of the superheated steam added if the specific heat capacity of steam is 2.1. So of superheated steam, you're saying HSU equals to, let's check the formula. The formula says Hg plus Cp. So yeah, it's Hg plus Cp into TSU minus TS. So then we need to find our Hg value. We go to our pressure for 920. Our Hg value, we have 2773. So it's going to be 2773 plus. So they gave us a specific heat capacity here. Our Cp value, which is 2,1 kilojoules. You don't need to convert this kilojoules only because all other values, your other enthalpy values are already in kilojoules. So there's a consistency of SI units. Your TSU, we have 210 minus our TS, saturated temperature. Saturated temperature, we can find it from the steam table. We have 176,3. There it is, 176,3 minus 176,3. You substitute this. So this is 2773 plus 2,1 into, let's see, this is 210 minus 176,3, close bracket. We have 2843, 77. This is what? Kilojoules per kg times 10 kg, 28437,7 kilojoules. I hope I'm not doing any mistakes. Let's confirm our HG again. HG 2773. Yeah, no, it's fine. Yeah, and that's our answer. Last question. Calculation says calculate the saturation temperature of the steam. 2.4. Our TS. So TS, we found it in the previous question. TS we found 176.3. So you just substitute it as is. 176.3. Our TS is measured in degrees Celsius. So degrees Celsius, and you are done. So this is just a basic question for steam. Let's look at this one. They have a tendency of giving us data in a very interesting way. Let's do this one. Number 6. Number 6. So for number 6, sharp. So pressure, né? Well, let's collect that. It says the dryness factor of 1 kg mass is given as 1 kilograms of wet steam is, our Q value is 0.94. Then they say the steam is generated at a boiling point of 2.5 megapascals. Pressure is given to us as 2.5 megapascal. So now the purpose of this pressure is to assist us to find our pressure on our steam table. On our steam table, we don't have pressures expressed in, what do they call them? Megapascals. As you can see, all our pressure values are in kilopascal. So we are required to convert this megapascal to kilopascal. So let's go through long dry quickly. Long dry would say you have 2, this is pressure. 2.5 mega is the same as 10 to the power 6 Pascal. You want to convert this to kilopascal, you would still divide it by 10 to the power 3 or 1000. So then your answer, you get something like 2.5 you get 2500 kilopascal. So there's a shortcut to convert from megapascal to kilopascal. You can just multiply by 1000. So if you multiply this value by 1000, you'll get the same value here. So let's revise it quickly. So what did we say? What did we say? We were saying we are given 2.5 megapascals. A mega is the same as 10 to the power 6. This is pascals. You want to convert this whole expression to kilopascals. Even if I write it, this is 2.5 pascals. I want to convert it to kilopascals, so I divide it by 1000. Then I still get 2500 kilopascal. This is long dry. So like we were saying, our shortcut to convert from megapascal to kilopascal, just multiply by 1000 that value. So here we have 2500 kilopascal. So later on we're going to refer to our steam table for the value for what do they call it? The value of the pressure. Yeah. Sharp. So let's move on. Yeah, let's throw this here for now. Sharp. Question says calculate the specific enthalpy heat energy of the following. So we're still looking for heat energy of the following. So we will be referring to a pressure of 2500 kilopascal. Now on the actual steam table, you should be careful as you page through the actual book, because directly in between that very book you have, I think, a superheat steam table again. It's directly in between that very book. So there's a case where you keep paging, and as you're paging, you get worried because you can't see your information. So just keep paging across that book until you find the pressure which they gave you. There's no case where they can give you a pressure which is not in there. So first question, it said calculate the what liquid enthalpy. They gave us the symbol HF as we're looking for HF. So HF at a pressure of 2500, it's 962. We write our answer. This is 6.1. HF, we have 962, okay, 62 kilojoules. This is kilojoules per kg times 1. It's the same answer there. So in cases when they give us 1 kg, you don't need to write the per kilogram because it's going to be cancelled. You just multiply the original value times 1 kg and we get this. 6.2, our Hg dryness fraction, dryness steam, our steam at dry conditions. So here we are this side, we have 2801. Rough lower. Hg 2801 kilojoules at 1 kg. 6.3 evaporation HFG. You refer to your steam table. Our HFG is around here, HFG, this value you have 1839 kilojoules. 6.4 enthalpy of wet steam, we have a formula for it. So that formula which says H wet, let's check. It says H wet equals to HF plus Q HFG equals to HF plus Q HFG. So for our HF we have 2801 plus Q, they gave it to us 0.94 times our HFG 1839, and then you do the things, plus 0.94 times 1839. Okay, we have 4529.66. I flopped my HF. I substituted the wrong value. Yeah, and busy lan jaja mo dipelong tsa lona. Here's HF, it's 962. So let's change this number. 962. Yeah. 2690.66. 2690.66 kilojoules. We're multiplying all these values by 1. That's why we're not writing per kilogram. Last one. Enthalpy to dry the wet steam. Alternatively, they'll say required to dry the wet steam. In this case, they wrote it as H1 minus X. We also know it as just H. Wait. Is it just H? Let's see. Let's see the question again. Enthalpy required to dry wet steam. Yes. Required to wet steam. So in our case, we know it as H. There are two formulas for this. I'm not gonna find the other formula, but the alternative one is this one here. HFG minus Q HFG. So in this case, we're saying this is what 6.4, 6.5, huh? 0.5. We're saying H equals to HFG minus QHFG. Our HFG, we have 1839 minus Q 0.94 times 1839. 1839 minus 0.94 times 1839, and then 1034, 10.34, 110.34 kilojoules, and you would be done. So the only reason why I jumped straight to this question is because of this 25 megapascal. So make sure you practice, answer the rest of the questions from your handout.